Alright, Chris, so I showed you with the sun how the angles all are going to be the same, but you didn't believe me. So can you measure the angles? I didn't want to do that, so I just mapped it out, did everything by eye. Alright, these toothpicks here all represents the viewer angle looking due east for every these ones. These ones right here are representing everyone's view to the sun. Because we believe the sun rays are all parallel to each other, they're all going to be parallel to each other as well. There's only one skewer on these ends because that's going to represent sunrise during the equinox. I chose the equinox because it's the easiest model to map out. As you can see, all of this toothpicks are pretty much pointed right at the camera. So this will represent sunrise, so angle to the horizon is going to be 0. This is about 6 hours later. As you can see, the angle do not change. Once again, 6 hours later, around noon time, the angle does not change. 6 hours later, the angle does not change. So this is about 45, this is about 90, that's about 135. As you can see, the angles do not change. But you're probably going to say, well, you're just making it because it's not per view. The reason why this happens is for this 15 degree per hour constant rotation works for everyone. But the axis of rotation arcs across the sky. That's polarly aligned. So with a single axis of rotation that's polarly aligned, that's aligned with this axis, you're going to have a constant 15 degrees an hour. This is how equatorial mounts work. I've made my own equatorial mount using 2 ball joints and filmed the sun, taking a picture every half hour at 7.5 degrees. And the sun did not move from the center frame. It's something you can do yourself. I have a video of it on how I made it. It's relatively cheap. If you ask, I'll link you to the video, or you can just look for mine. It's the Wolf Feet Challenge video. But as you can see, the angles do not change. The angular speed is going to be the same no matter what the latitude is. And the only reason why this can happen is because the sun is 93 million miles away and it's enormous. With the sun that far, the parallax for the viewer will be minimized. The change in distance from here to here is minuscule versus the distance to the sun, which is completely opposite what the flat earth believes, because you believe in a close sun. So for every viewer that's not on the North Pole, the angular speed will have to change throughout the day. I'll show a video of this later on. But the main thing is that the distance to the sun is going to change drastically. When the distance change to the sun will be a large portion to the distance to the sun. And this will cause it's almost like watching a race car going around a track, going at a constant rate. You're watching it from close, and you're watching it from far away. The angular speed will be much faster when it's close than it is when it's far away. That's what parallax is. This is what you're trying to describe in your video, but this only works with a close sun. Unfortunately, the globe model doesn't believe in the close sun, only the flat earth model. So thank you for debunking the flat earth.